Okay, so I want to do one like this. So not A, if we do the shading with kind of colors, not A is everything like out in this kind of universal set and parts of B, parts of C, but nothing that overlaps with A. All right, so that's my not A. Okay, and then not B would be not B. I'm going to cover up the B set and shade everything that's not B. So that's part of A is in there, the outside part of the universal set. Part of C is in there. And again, the outside part. So nothing in B is shaded. Okay. So, and so I'm looking for the and. This is the overlap. So this is kind of hard because they both have to be shaded. So what parts are both shaded? Well, it looks like this outside part is both shaded. So I'm going to use a green highlighter, anything that's double shaded. So this is double shaded. This down here is double shaded, double shaded. The outside part of C is double shaded, and the universal set on the outside is double shaded. But all of A and all of B and their overlap is not shaded. So the answer is this. Now again, if you're like, oh, you know, that's kind of complicated. Okay, what we can do is, I'm going to make a little, you know, A, and then we'll do what? They put C over here, and they did B over here, C and B. All right, so I'm going to put the number 1, 2, 3, 4, 5, 6, 7, and then 8 on the outside. So I'm putting numbers in all my sets is what I'm doing. So A by itself has 1 if it's out in that space, 2, 3, 4 where it overlaps, 5 is C only, 6 is the overlap part, and then 7, and then 8. All right, so what I do is I answer the question. So not A, I'm going to cover up A. Not A is the numbers 5, 6, 7, 8. Okay, not B, I'm going to cover up my B set. So 1, 2, 5, and 8 are my answers to that. 1, 2, 5, and 8. And I'm looking for where they overlap, the and. So they have a 5 in common and an 8. So they have a 5 and an 8. Both of them do. So that's the intersection. So then what I'm going to do is I'm going to shade the 5 part and the 8 part, which is the outside. And notice I get the same answer. So if I don't want to think about it, I can just do what we call paint by numbers. All right. So I'm going to do, let's look at one of these on the next page. And again, these can have over, you know, kind of order of op with them. I'm going to redraw this because usually when we draw these, a lot of times they'll have A and B on top and C on the bottom. So I just want to see, draw it a little bit different than they did here. So if I put A here, B here, and maybe C on the bottom, I'm going to number 1, 2, 3, 4, 5, 6, 7, 8. Okay. And again, set A has 1, 2, 3, or 1, 2, 4, and 5. Set B is 2, 3, 5, 6. Set C is 4, 5, 6, 7. And then 1, 2 through 8 is the whole universal set. All right. So not A. Okay. We're going to do that last because order of operations, please excuse my dear Aunt Sally. We're going to do this parenthesis first. So not C. What is not C? So cover up C. 1, 2, 3, and 8. So I have 1, 2, 3, and 8 is my answer to not C. Because I take the universal set, take everything that's in C out. Whatever's left is that answer. Okay, and I'm going to intersect that because I have parentheses with B. So what is B? 2, 3, 5, 6. Okay, 2, 3, 5, 6. Okay, so what do they have in common? Overlap means I'm looking for what they have in common. So it looks like I have a 2 and a 3 in common. All right, so the answer to that part is just because there's a 2 and 3 over here, 2 and 3 over here. Okay, so the answer to that part is 2 and 3. And now I have to take that answer and union it with not A. So I did this parenthesis and I got this answer, 2 and 3. Now I have to union it, okay, with not A. Okay, so I'm going to go back up here. I'm going to cover up A. So not A would be 3, 6, 7, 8. So not A is 3, 6, 7, 8. And union means lots of junk. Remember, union means bring it all in, unify, bring everybody together, right? Or like a marriage, you have his, hers, theirs, ours, the kids' junk, lots of junk. So you get a big answer here. So when I unionize it, I get what? 2, 3, 6, 7, 8. And again, you don't do duplicates. So 2, 3, 3 is a repeat, 6, 7, 8. So then in my picture, I know I'm going to shade the 2 part, the 3 part, and then the 6 part, and the 7 part, and the 8 part, the whole outside part here. Okay, and that's going to be shaded. That's my answer. 1, 4, and 5 are not shaded. Okay, all right, so that's how you can do those shading ones. All right, let's talk about a Venn diagram. All right, so we can use these to try to get rid of double counting, and these are super popular in statistics. So remember, if I ask you, like, how many of you have brothers, you know, out of, say there's 24 of you, and I say, how many of you have brothers? And maybe, I don't know, 10 of you say yes, okay? And I'm like, okay, great. And I'm, again, either a brother or brothers. And then I say sisters, you know, how many of you have sisters? And say, you know, 16 of you say yes, right? It's like you have a sister or sisters, okay? Great, okay? But some of you might be like, but that's 26 people and there's only 24. Well, you know what? Don't some of you have both brothers and sisters? Is that possible? All right, so then I might say, okay, both. How many of you have both? And say that 8 of you say, yes, you have both. Okay, and we're going to change this problem over here. We're going to do the one I'm giving you. Okay, so we have brothers and sisters, and both is in the middle. So we can use a Venn diagram to help us out. Okay, the universal set is this entire class, all 24 of us. Okay, so do you get that these people might have said, like if you asked me if I had a brother, I'd raise my hand, right? If you said, Julie, do you have a sister? I would raise my hand. And if you said, do I have both? I'd raise my hand again. So I might raise my hand 3 times. So we have to get rid of double counting. So I'm going to start with the both. So there were 8 of you. So if we were in a face-to-face class, we would, you know, obviously do this for real. And then I would ask you a question like, how many only children are in the class? And how many have just sisters? How many have just brothers? Okay. And you can figure that out just with this data. So both is here. All right. Now, the people, there were 16 people that said yes, but 8 of them said yes to both. So there's really only 8 people that, you know, just have sisters. So if you look at the sister circle, we have 2 intersecting circles, and we put the 8 in the middle for the overlap. But do you see I'm circling in green the sister circle? 8 plus 8 adds up to 16, which is good. I had 16 people, but I also had 8 that said both. And so I can see them separated. 8 plus 8 is 16. Okay, what about brothers? Well, I had 10 that said yes, but I had 8 that said both. So part of them have already been counted. The 8 that have both are counted. So that means there's just 2 out here that just have brothers. And I'm going to highlight that in yellow. So if I look at the kind of yellow circle here, all right, that's my brother circle, and I have 8 that had both, and then I have 2, so that adds up to 10, which is great. Okay, so now I'm ready to do the total for the class. There's 8 and 8 is 16, 17, 18 people, but there's 24 students in the class, right? So if I have my 18 and I subtract it, that means there's 6 people that, you know, they never raised their hands. So that must be the outside part. So our universal set is people who have siblings, right, or don't. And so there's, you know, I can kind of separate it by that, okay? All right, and again, if that, you know, that's kind of just a simple idea, all right, or a simple situation. So let's look at kind of maybe like people that are in classes, right, because maybe you don't relate to that one very well. So hopefully we'll maybe relate to this one. All right, so let's see, she has some people in finite math. She notes that 15 said they like donuts, 25 students said they like bagel, 5 students were absent that day, were unable to respond, assuming that everyone who was present answered. How many students like both bagels and donuts? It's like, okay, all right, so let's kind of think about this. All right, we have our what? We have our bagel students, and we have our donut students. And how many were not there? 5 were absent that day. So everyone okay? The 5 people that didn't answer, they're out here. I don't know what they like, right? So they just didn't answer. Let's see. She notes that 15 students said they like donuts. Okay, so this whole circle has to add up to 15, but I don't know how it's divided up, right? And the whole bagel one has to be 25. All right, and let's see. 25 like bagel, 5 were absent that day. Okay, all right. So, and there's what, 35 students in the class. Okay. All right, so there's a nice little union rule that helps with this, okay? And so I'm going to flip back here. The union rule says that the number in A union B, which is all these added up, is how many are in A, how many are in B, but you have to subtract the double counting, okay? So if I know how many like donuts, great, add them. How many like bagels, great, but I have to subtract my double counting. That's the problem, okay? So let's look at that formula. All right, so my total, I know there's what, 35 students in period 2. Okay, but I'm going to take away the 5 that, what, they weren't participating that day. How about 30? That's better. 30. So I have 30 people that are in these 3 circles. Okay, so the number in the bagel circle, all the bagel circle, is 25. That's everybody, including some overlap there. That's a problem. The number that is in the donut circle is what? 15 said they like donuts. Okay, so there are 15 in the donut circle, but there's some overlap there, right? And so this union rule says if you add all the bagels, all the donuts, you better subtract your double counting. So I'm going to put an X in there to equal the circles added up. So that would be all 3 parts added up, which is 30, right? Because we have 35 people and 5 didn't vote. All right, so let's add that up. What is that? Is that 40? Minus X equals 30. So that would have to be, X would have to be 10, right? So X equals 10 because 40 minus 10 is 30. So there must be 10 people in the overlap. Let's see if that works. All right, so 15 said they like donuts. 15 minus 10 is 5. So there's my 15. Okay, bagels are 25. 25 minus 10 is 15. So that gives me 25 people that like bagels, 15 that likes donuts, and 15 plus 15 is 30, 35 people total. All right, so that's good. All right, let's try another one with a Venn diagram here. Let's look at this one. All right, so this is one with 3 things going on. Let's see, we have, I'm going to make a 3-pronger here. So we have what? Business Week magazine, Wall Street, and then we have Fortune. Okay, all right, so usually looking for the both is good. Let's see, 9 people read all 3. Now this is a 3 thing, so the middle is people that read all 3. There's 9 people there. All right, so I did that. Okay, Business Week and Fortune. 13 people read Business Week and Fortune. So where's Business Week and Fortune? That's kind of this little almond shape here. And so 13 people, but the 9's already there. So I have to subtract from 13. So 13 minus the 9 people that I'm already counted, there's 4 people I haven't counted. So do you see there's 9 people that read all 3. So they count towards the people that read 2 of them. This does not say they read Business Week and Fortune, but they did not read the other one. Doesn't say that. They just read Business Week and Fortune. So there's my 13 people there. All right, so I'm going to cross that off. 11 read Wall Street and Fortune. Okay, where's Wall Street? Okay, so Wall Street and Fortune is kind of this almond shape. That's 11. But again, it doesn't say they didn't read the other one. It just said they read those 2, okay? So Wall Street and Fortune are here, and it's 11. So the 9 people that read all 3, they're part of that 11. So 11 minus 9 means there's 2 people just out there. Okay, and let's see. Let's read the next one. 11 people read Business Week, but not the Wall Street Journal. Okay, so Business Week readers, okay, but not the Wall Street Journal. 11 people read Business Week. Okay, so here's all my Business Week people. Are you okay with that? That's all my Business Week people. But it said all those Business Week people, 11 people read Business Week, but not the Wall Street Journal. So I need to get rid of anybody that overlapped with the Wall Street Journal because it said they read Business Week, okay, but they did not read the Wall Street Journal. So those 9 in the middle, they read the Wall Street Journal, and these people would have too. So what is that? 11 minus 4 is 7. Okay. Let's see, what else do I need? Business Week. Let's go to the top. 25 read Business Week. Do you see how I know 3 of my 4 pieces? So 7, 4, and 9, all of this whole circle is 25. So what do I have? I have 11 and 9, so that's 20. So 25 minus the 20 I've already counted is what? 5 people out here. Okay, so then that circle all has to add up to 25. 19 read the Wall Street Journal. Okay, so let's look at just Wall Street Journal. We have 9, 2, and 5. So that's what? 11 and 5 is 16. So 19 minus 16 is what? What is that? 3.